In the late 1950s, a team of top American generals stood in a dark room watching Soviet missiles blow their best spy planes out of the sky. Every time a jet flew over enemy territory, Soviet radar hit it. A red dot flashed on a screen, and a missile ripped the plane to pieces. The generals wanted a faster plane, with thicker armor. Kelly Johnson stood up in the meeting, looked the generals in the eye, and told them their idea was completely stupid. Johnson was the head of Lockheed's super-secret Skunk Works division. He didn't care about rank, he didn't care about tradition, and he certainly didn't care about hurting the generals' feelings. He told them that adding armor made a plane heavy. A heavy plane was a slow plane, and a slow plane was just a bigger target for a Soviet warhead. The generals demanded to know how else they were supposed to hide a massive titanium jet from Soviet radar. Kelly Johnson picked up a piece of chalk, drew a simple stick figure of an airplane on the blackboard, and said 5 words that would change aviation history forever. "We make the radar lie." That moment birthed the SR-71 Blackbird, a machine that would face over 4,000 enemy missiles, fly at 3 times the speed of sound, and never suffer a single scratch. To understand why everyone thought Kelly Johnson was crazy, you have to see what happened when a normal plane flew into radar range. Imagine an enemy radar dish as a blind guy throwing thousands of tennis balls into the sky every single second. When a traditional jet with big round engines, flat wings, and a straight vertical tail flew past, those tennis balls hit the flat metal and bounced straight back into the blind guy's hand. The blind guy knew instantly where the plane was, how fast it was moving, and where to fire the missile. Every aerospace company in America was trying to build smaller tennis balls. Kelly Johnson realized that was a total waste of time. He didn't care if the enemy threw tennis balls. He was going to build an airplane shaped so weirdly that when the tennis balls hit it, they would bounce off sideways, backward, into the clouds, down into the dirt, anywhere except back to the blind guy's hand. If no tennis balls bounced back, the radar screen stayed completely blank. The plane became an invisible ghost. Johnson sprinted back to his secret Skunk Works facility in California, locked the doors, and started drawing shapes that made conventional aerodynamic engineers throw up. At the time, airplanes were built like flying tubes. They had round noses, straight wings, and big vertical tails pointing straight up at a 90-degree angle. Johnson took an eraser and wiped the traditional design off his drafting board. First, he looked at the nose of the plane. Instead of a smooth, round cylinder, Johnson stretched the sides of the nose out into razor-sharp, knife-like horizontal edges called chines. When his engineers saw the blueprints, they told him he was insane. They said razor-sharp edges on the side of a cockpit would ruin the plane's aerodynamic lift and cause the jet to tumble out of the sky like a dead rock. Johnson didn't listen. He built a scale model and threw it into a wind tunnel. Not only did the sharp chines scatter radar waves sideways like a mirror tilted at an angle, but at supersonic speeds, those sharp edges created massive mini tornadoes of air over the wings. Those air vortices generated insane amounts of extra lift. Johnson had accidentally solved 2 impossible problems with one single stroke of his pencil. Next, Johnson turned his attention to the vertical tails. Every jet in the world had vertical tails sticking straight up. Johnson knew that a 90-degree corner between a wing and a tail was the ultimate radar trap. It functioned like a giant neon sign screaming, "Here I am," to Soviet ground stations. So Johnson took the tails on his blueprint and physically tilted them inward at 15 degrees. When radar waves hit those slanted tails, the energy bounced uselessly up into space or down into the desert sand. When the military ran computer simulations on Johnson's weird, flat, slanted design, the results broke the system. A jet over 100 feet long, carrying thousands of gallons of explosive fuel, showed up on radar as a target smaller than a medium-sized bird. But designing an invisible shape on paper was only 10% of the nightmare. Now, Kelly Johnson actually had to build the damn thing, and that's where the engineering paradise turned into an absolute war zone. To fly fast enough to outrun enemy missiles, the Blackbird needed to travel at over 2,000 miles per hour. At that speed, friction with air molecules turns the metal skin of an airplane into a glowing furnace reaching over 600 degrees Fahrenheit. If you built the Blackbird out of aluminum like every other jet on Earth, the plane would literally melt into a puddle of liquid metal mid-flight. The only metal on the planet capable of surviving that intense heat without warping was titanium. There was just one massive, embarrassing problem. The United States didn't have any titanium. The largest natural supply of high-grade titanium ore on Earth was sitting inside the territory of America's primary Cold War enemy, the Soviet Union. Kelly Johnson went directly to the CIA with a plan so absurd it sounded like a Hollywood movie script. The CIA created dozens of fake, bogus commercial shell companies all around the world. These fake companies, ranging from international shipping firms to dummy import-export businesses, quietly began buying thousands of tons of raw titanium ore directly from the Soviet government. The Soviet Union literally sold the United States the exact raw material used to build the ultimate spy plane, designed to fly over Moscow undetected. When the crates of Soviet titanium arrived at the Skunk Works factory, the real nightmare began. Titanium was a nightmare metal. It was so hard and brittle that traditional steel drill bits melted or snapped the second they touched it. Machinists at Skunk Works were quitting out of sheer frustration. Tools were breaking every 5 minutes. Parts were cracking in half. Johnson walked through the factory floor, inspecting the broken parts, and realized another invisible detail everyone else missed. The local tap water in Burbank, California, contained high levels of chlorine. When workers washed the titanium parts, the microscopic traces of chlorine were reacting with the metal, making it brittle and causing structural cracks under pressure. Johnson banned tap water from the entire factory. From that day on, every single bolt, screw, and titanium panel of the Blackbird was washed exclusively with pure distilled water. To cut down tool breakage, Johnson forced his team to invent entirely new diamond-tipped drills, heat-treating processes, and manufacturing techniques from scratch. Next came the fuel problem. At room temperature on the runway, the Blackbird's titanium skin panels were fitted together loosely. Why? Because when the plane accelerated to Mach 3, the extreme heat would cause the titanium hull to expand by several inches. If the panels were tight on the ground, the plane would burst its own seams in midair. Because the panels were loose on the ground, jet fuel literally leaked out of the belly of the plane onto the tarmac, dripping all over the floor while the aircraft sat on the runway. Normal jet fuel would have ignited immediately on a hot runway, blowing the airplane and the pilot to pieces. Johnson had to call chemical companies to invent a brand new, ultra-stable synthetic fuel called JP7. JP7 was so chemically stable and resistant to fire that you could take a burning match, throw it directly into a bucket of JP7 fuel, and the match would simply extinguish itself. The fuel required special chemical igniters just to start the engines. Finally, Johnson ordered the entire aircraft painted in a custom, deep blue-black paint. This wasn't for night camouflage. The paint was packed with microscopic iron ferrite particles. When enemy radar waves struck the painted skin of the Blackbird, the iron particles absorbed the electromagnetic energy and converted it directly into heat, trapping the signal before it could bounce back. The airplane wasn't just reflecting radar, it was actively eating it. On April 22, 1962, the first prototype took off into the skies over the Nevada desert. It looked like an alien spaceship dropped into the middle of the 20th century. A few years later, the operational SR-71 Blackbird was deployed to military bases around the world. The ultimate test of Kelly Johnson's vision wasn't in a sterile laboratory or a computer simulation. It was over hostile enemy territory, packed with anti-aircraft missile batteries. Imagine you are a Soviet radar operator sitting in a cold bunker in the late 1960s. Suddenly, a tiny, faint flicker appears on your radar screen. It doesn't look like a giant strategic reconnaissance jet. It looks like a small lost bird or a glitch in the radar receiver. By the time your computer algorithms process the signal and realize that small bird is actually a black titanium monster flying at 85,000 feet, the aircraft is already traveling at 3,300 feet per second. Panic erupts in the bunker. You scramble your surface-to-air missile batteries. The radar locks on, and a massive, multi-stage missile roars off the launch pad, screaming into the upper atmosphere to intercept the intruder. Inside the cockpit of the SR-71, a red warning light flashes on the control panel, indicating a missile launch from the ground below. In any other aircraft in history, the pilot's reaction would be to dive, turn hard, deploy chaff, and pray to survive. In the Blackbird, the pilot's official flight manual instruction was simple, cold, and arrogant. Push the throttles forward. The pilot shoves the twin controls into full afterburner. The massive Pratt & Whitney J58 engines gulp down thousands of gallons of JP7 fuel, converting the jet engines into raw ramjets. The Blackbird surges forward, accelerating effortlessly from Mach 2.8 to Mach 3.2, climbing higher into the black atmosphere. On the Soviet radar screen, the missile's tracking computer calculates an intercept point. But the Blackbird is moving so fast that it outpaces the missile's turning radius. The missile burns through its entire supply of solid rocket fuel, stalls out in the thin upper air, and tumbles harmlessly back down to Earth, exploding uselessly in the clouds thousands of feet below the Blackbird. The SR-71 pilot looks out the titanium window at the black sky above and the curvature of the Earth below, cruises smoothly over the target zone, takes high-resolution reconnaissance photos, and flies home in time for dinner. Over 30 years of operational service during the height of the Cold War, enemy forces fired over 4,000 missiles at the SR-71 Blackbird. Not a single missile ever hit its target. Not a single Blackbird was ever shot down. Not a single pilot was ever lost to enemy fire. Consider what would have happened if Kelly Johnson had listened to the military generals in that meeting back in the late 1950s. If Lockheed had built a heavy, armored, traditional jet, dozens of American pilots would have been shot out of the sky, billions of dollars would have been wasted, and the United States would have been blind during the most dangerous moments of the Cold War. Traditional aerospace engineers looked at radar as an unstoppable force of nature that had to be beaten with brute strength, faster engines, and thicker steel. Kelly Johnson saw that radar was just light that humans couldn't see, and light could be tricked using clever angles, sharp edges, and pure geometric genius. By bending metal at precise angles, tricking his own enemy into supplying the titanium, and having the courage to challenge every rule in the aviation handbook, Kelly Johnson didn't just build a fast airplane. He created a flying phantom that redefined the laws of warfare and proved that simple geometry can conquer the most dangerous weapons on Earth.